It's like a mirror, okay? Thinking about this little triangle here, where do you think I could draw a line that it would
In the middle.
out in the middle. This right here is line symmetry. If I fold it on that line, it'll match up onto itself. Okay? Just because it has line symmetry doesn't mean that it works wherever. Okay? It only works where it has the line symmetry. So just because this triangle has line symmetry does not mean that this is a line. If I fold it on that line, does that work?
No.
No, not a
I
chance.
know what that was.
So it is possible for shapes to have like one line of symmetry, could have 800 lines of symmetry.
You can
Okay.
have either.
What?
You can have either. Does that make sense?
Sure. Okay. Point symmetry is kind of like rotational symmetry. If it has point symmetry, think about it rotating 180 degrees. Okay, so in this case, if I put a little dot here and rotate it 180 degrees, I'm still getting the same image. Okay, think of it like if it's upside down. Or left, right. A square, does a square have point symmetry? If I rotate it here, 180, does it still look like itself?
Yeah.
Yeah. What about if I have this triangle? If I put a point here and I rotate it 180 degrees,
No, it's gonna be upside down.
right, that's like that. That's not mapped onto itself.
Yeah.
Okay? Yeah, exactly. Right. And then lastly, we have our rotational symmetry. If it can be rotated onto itself less than 360 degrees, okay? So it kind of depends on the shape. Pinwheels, something that looks like it's a rotated copy of itself. In this instance, if I put a dot there, I can rotate it from each little triangle thing and it's going to look like itself. Okay, something I do want you to write maybe to the right of this, your angle of rotation. To find your angle of rotation, you're going to take 360 divided by the number of things. Okay, and I know that's not very specific, but I'll explain it once you write it down. Okay, what I mean by the number of things is look at this picture. How many things are the same? How many little triangles do I have? 8. So to find your angle of rotation, you're going to take 360 divided by 8, and that's 45 degrees. So I can rotate this 45 degrees, which kind of makes sense because this is 90, so half that's 45. Every 45 I rotated it, it looks the exact same. Okay? If I had like a circle and then little lines like this, how many things do I have? 4. So you take 360 divided by 4. Does that things thing make sense?
Yeah.
Okay. So it's whatever your thing that's the same. Okay. So we're going to go through these and you're going to tell me if they have line, point, rotational, or no symmetry in them. If I look at number 1, my hexagon, can I draw a line down it and it will reflect on itself?
Yeah.
Yeah. It doesn't matter how many, as long as I can come up with one. Maybe that one. There's definitely more than one, but as long as you can come up with one, it has line symmetry. What about point? Can I put a point in the middle? And then it will reflect on itself?
Yeah.
Yeah.
Yeah? If I turn it 180 degrees upside down?
I think so.
Yeah. Think about this line. If I rotate that 180, isn't that just that line now? Yeah, it has point. What about rotational? Yeah? Same thing, I can take this little dot and make this line, make this line. All the lines, the lengths are the same. So I can rotate it. number 2? Can I draw a line down that and have it be symmetry?
No.
Yeah.
Oh.
Can I rotate it 180 and it'll land on itself? No, so it doesn't have point. Can I rotate it?
Yes.
Yeah. Number 3, does that have line symmetry?
Yep.
Well, you can do it diagonal.
Okay, if I do it diagonal, this is gonna end up like short over here.
No, come.
So there's no line. Oh, there we go. What about point? If I put a dot here and rotate it 180, will it land on itself?
Yep.
Yeah. Can I rotate it so that it matches up? No? Didn't we just say we could rotate this 180 degrees and it match on itself? Yeah. So anytime it's going to have point, it's going to have rotational as well. Okay? It can have, like if you look at number 2, it can have rotational without having point. But every time it has point symmetry, it will have rotational symmetry. Because if it works with 180, it's going to work rotating at 180. Look at number 4. Can I draw a line somewhere on there?
No.
And mirror it on itself? No. Can I flip it upside down? No. Can I rotate it any degree and have it look like itself?
No.
No. So this one's got nothing. How about our star? Can I draw a line and have it mirror on?
No.
Yep.
What? Oh yeah. It's
Yeah.
a star. Yes. Yeah.
Can I flip it upside down and have it look like itself?
Yeah.
No.
If you flip it upside down.
If I flip it upside down, I'm gonna have like, you don't even want to see me draw, like a 2 and then a 1 down here, right? If I flip it upside down,
Oh yeah.
does that
No.
make any sense?
Yes,
You
it
can
does.
have these
Yeah.
2. Okay. Can I rotate it though?
Yes, you can.
Yeah. If I actually find the angle of rotation, you take 360 divided by what? 1, 2, 3, 4, 5. 6. What?
Wait, what?
What? Nothing. Number 6, can I draw a line and have it match up?
No.
No, because if I draw a line here, it's missed. If it's here, it's missed. Lines, no. Can I flip it 180, flip it upside down, and have it look like itself?
Why yes, you can.
Yes. If I flip it 180, I go and it's right on top of itself. So if it's point, does that mean it's rotational?
Yes.
Yes. The letter A. Can I make line symmetry from there?
Yep.
Yep. Can I flip it upside down?
Nope.
No.
Nope. Can I rotate it at all?
Nope.
Nope. Just line. And my lightning bolt, can I draw a line?
No.
No. Can I flip it upside down?
No.
Can I rotate it at all?
No.
We got none.
Shape.
Oh
Okay.
my god.
Go to your flip book, and we're going to skip dilations for now. Go to that identifying transformations.
Well, there's a lot.
There is not really serious one,
Oh, there's a bad noise. Hold on, there's a bad noise.
Okay. Remember we talked about how things have an image and a pre-image? The pre-image comes first, the image comes second. How do I know, like with 21, how do I know which one I started with?
The one that doesn't have the little images.
Yeah, the one that doesn't have the apostrophe, the little dashes, whatever you want to call them. So we actually start with this picture right here. Okay, that's where we start with. Our transformation, the things we've talked about is what we got in our flip book. Our reflections, translations, and rotations. What happened there? Did we translate? Did we slide it? Did we reflect it, flip it? Or did we turn it, rotate it? We slid it, yeah. So we got a translation. How do you know that we just slid it?
It's the same shape, just moved over.
It's just moved over, yeah. I personally like to pick point J, new J is right there. It's still on the left and kind of upper part of your triangle, so it didn't get rotated, flipped, anything. It's still on upper left to upper left. Okay? Our rule, well, what happened? If this is where we start, did we go left, right?
We went left.
Left. Did we go up or down?
Up.
Up. So we went left. How much left did we go?
4.
4. How up did we go?
4.
So we got those rules. Our rules, remember, we got this fancy little form. XY becomes, if I'm going to the left, good, that's a minus. If I'm going up, that's a plus. So we have x minus 4, y plus 4. Okay. 22, did I start with the left picture or the right picture?
Right.
The right picture, this is where I started. Okay, let's look at Q. Here's old Q, here's new Q. Q starts on the bottom left, it ends on the bottom right. So what happened to it? It reflected, yeah. What did it reflect in? What line did we reflect over?
The Y.
The y-axis, yeah, how do you know? It's in the middle of them, yeah. If you look at Q, it's one away each side from your y-axis. So our rule, we just reflect in the y-axis. Questions on either of those two? Okay, we're going to skip 23 for right now. 24, which one did we start with? The one top left or bottom left?
Top left.
Top left, we started with this one. Let's take Z for example. Starting Z is up here, ending Z is down here. Did I translate it?
No.
Did I reflect it?
No.
No, I rotated it. How many degrees do you think I rotated it? 90.
Oh.
If I go 90 this way, is that clockwise or counterclockwise? Counterclockwise. Or you can write 270 clockwise. If they are right next to each other in your boxes, that's a 90. If they're reflected or opposites, that's a 180. Then you just have to think, did it go down or up or up? 25, we're going to skip. 26, which one did I start with?
Top one.
I started with top. Let's look at U. U is in the bottom right when it starts. When it ends, it's still in the bottom right. So what happened? Translation. Did it go left or right?
Nope.
No. Did it go up or down? Down. How much?
Yep.
9?
Yep.
So our rule, we start XY. How do I finish that? If I don't go left or right, what do I write down?
X.
Yeah, just X. And then what do I write for the Y star?
Minus 9.
Y minus 9. Good. We just write X because nothing happened. It didn't move left or right. Okay. Good there?
Yeah.
Okay, 27. Which one did I start with?
Top one.
Top one. Let's look at C. C's in the bottom left. If I look at my new one, it's in the top left. What happened to it? Rotation. How much did it rotate? What did you say, bud? 270 which way? 270 counterclockwise, aka 90 clockwise. And 28, which one did I start with, top or bottom?
Bottom.
Bottom, let's look at K. K starts in the top right, ends in the bottom right. What happened to it? Reflection. Over what? The y-axis?
No. 3y.
You look in between them, the K's is this line right here. True?
Mm-hmm.
That's in the middle of them. Lines that go left and right are y equals. Y equals 1, 2, 3, negative. Okay. How we feel about stuff?
Good.
Good?